Okay, now we're going to fill in this. I've tried to sketch a few of these things, or at least part that might help us count for a triangular prism. We know we've got the two triangles, and then we're going to have the lateral faces that connect two triangles together. So the total number of faces, we've got two triangles. We've got those two, and then each triangle has three sides. Those sides with rectangles. So that's a total of 5. We've got the two triangles, we've got the two bases, and then we're going to have 3 bases. The number of vertices, you've got 3 on a triangle, and so you're going to have 3 on the other triangle, so that's a total of 6. Total number of edges, I've got 3 around this triangle, 3 around that triangle, and then I've got, so 3, 6, 9. A rectangle, got the 2 rectangles, so I'm going to have those 2 bases, and each base has 4 sides. So I'm going to have 4, 5, 6 faces. The number of vertices, each one of these rectangles has 4. So 1, 2, 3, 4. And then the total number of edges. So I have an edge 1, 2, 3, 4, 5, 6, 7, 8. I'm going to have 9, 10, 11, 12. Okay, a pentagonal prism. So for the total number of faces, I'm going to have 2 bases, and then I've got 5 sides that need to be connected. So 2 plus 5 is going to give me 7. The number of vertices, I've got 5 right here, and I've got 5 over there, so that'll be 10 vertices. The total number of edges, 1, 2, 3, 4, 5 edges, 6, 7, 8, 9, 10, and then I'm going to have 11, 12, 13, 14, 15. A square pyramid. So a square and the number of faces, so that's going to be the base, and then there's going to be 1 triangle, 2 triangle, 3 triangle, 4 triangles. So there's going to be a total of 5. The number of vertices, 1, 2, 3, 4, and then the 5th one at the top. The total number of edges, 1, 2, 3, 4, 5, 6, 7, 8. A pentagonal pyramid. So there's my pentagon, vertex up at the top. Gonna have, it's got 5, it's got 1 base, 1 pentagon that's a base, and then it's gonna have 5 triangles that go up to the top. So 1 plus 5 is 6. And then the total number of vertices, it's got 5, and then it's going to have 1 at the top. So it's got a total of 6. And the number of edges, we've got 1, 2, 3, 4, 5, and then each vertex is going to have 1 going up to the top. 1, 2, 3, 4, 5. So that's going to be a total of 10. Now they want me to see if it has 7. Now pay attention. A square has 4 sides. A pentagon has 5 sides. And on this one, I had 5 bases. On this one, I had 6 bases. So I'm assuming that with the 7 right here, if I do 1 less, I'll have 6. So that means it's a hexagon. And it followed this pattern. We went 5, 5, 8, 6, 6, 10. Here we went 7, 7, 12. So I'm assuming that since it followed the same pattern as the pyramids, then it'll be a pyramid too. Okay, so this one also looks like it's going to be a pyramid. So it's going 4, 4, and the next number. So we'll see. Since this was the same one each year, take one away from that, so that will be 3. So we know that's a triangle. Triangular pyramid. Okay, pyramid. And let's see, we went 4 more here, which was 1 less than that. We went 3 more there, which was 1 less than that. And so we're going to go 1 less than that and go 2 more here. So I believe that's going to be a 6. Okay, now this one, we go from, if it is a pyramid, we would go 8, 8. That would mean it would be a heptagon because it would have 7 sides. And then we would add more here. So it would be 8, 8, and then 14. So this is not the right number, so this is going to be a prism. Right, so let's see. When a triangle has 3 sides, it had 5 faces. A rectangle has 4 sides and it had 6 faces. A pentagon has 5 sides and it had 7 faces. So it looks like the number of faces that it has for a prism is 2 more than the number of sides of that shape. So take 2 away from this and I believe we get a hexagon. Okay, and then let's see what was the next pattern. For the number of vertices, it was 1 more here. So for vertices, 1, 2, 3, 4, 5, 6. That was this number right here doubled. And vertices was this number right here doubled. And this one right here was this number right here doubled. So it looks like vertices is going to be 6 doubled, so that should be 12. So that's just checking out some patterns, list any patterns that we've already talked about those. So you could write those down for a prism, and then write them down for a pyramid. So what was the pattern for a prism? Faces, it's the sides, the number of sides on the base, plus 2 for your faces. And for your vertices, what did we say? It was the number of sides on the base times 2. And for your edges, it was sides times 3. The number of sides times 3. We had 4 times 3, 5 times 3, 3 times 3. And then for a pyramid, it was faces equals vertices. And then edges, what was edges? Edges over here was, for a pyramid, it was sides double. Number of sides of the base times 2. All right, those are just some of my observations. You could maybe come up with a different one. It says, write a rule that expresses the relationship among vertices, faces, vertices, and edges. So it's kind of hard for me to pretend like I don't know this one because I do. So you take the number of faces, you add the number of vertices, and that's equal to the number of edges plus 2. Now that is an equation that can be solved for many of those variables. So, if you see it, and I believe that's called Euler's, it's one of Euler's rules or laws or formulas. And it's spelled E-U-L-E-R. Looks like Euler, but it's pronounced Euler. Okay, we can talk about different views. So if we imagine this hexagonal pyramid, if you hold it up and look at the bottom so that you can't see that it's got triangles coming off the sides, then this will be all you see. Okay, if you set it down and you stand directly above it and look down, this is what you see. So this would be a bottom view. This would be a top view. And it looks like this right here would be the side view. I can imagine putting this on the table and then moving my eyesight down so that it's level with the table so that I can't see anything along the sides. That's kind of what it would look like. I couldn't really see those dotted lines inside there, but this is the side view. The dashed segments mean that there are in the background, those are sides or lines or edges that we would see in the background. If our thing was see-through, we would be able to see that. But if they're not, then we represent them with the dotted lines. All right, so they want us to sketch the top, the bottom, the top, and the side views. Well, the bottom view, we held it out so that we couldn't see anything. It looks to me like we would have a rectangle. Okay, that's the bottom view. And the top view is going to look exactly the same. Why? Because the bottom and the top are the same. They should look the same. The bottom view, the top view, and the side view. So if you're looking at it from this side is all you can see. It looks like it's a little bit shorter. This is the side view. So if you were looking at it just straight down, all you could see would be that top. You're looking at it straight from the bottom, all you'd be able to see is that bottom. If you're looking at it from the side, all you'd be able to see is this side right here. So that's what you have to practice doing. Okay, it says if the bottom of the solid formed by this net, if the bottom is face B, sketch the top, front, and side views. Okay, so that means that if the bottom of the solid formed by the net shown is face B. Okay, so if let's see. This looks like that's the bottom. Then C is going to be a side. All right, so if I look down from the top, this is hard. I think it's going to be like a pyramid because there's only 3 things. So if there's only 3 things, then it's going to have to be a pyramid. So B is going to be on bottom. So I'm going to have B on bottom. And then C is going to come up, and then it's going to come up, and then D is going to come down like that. Okay, so I'm going to have C on this side and then D on this side. So the top is going to be like a triangle, and these sides right here are going to close these in. This will be side E, and then down here we'll have another triangle that will close that in, be side A. So when I'm looking down at the top, I'm going to see some of C and I'm going to see some of D. So I'm assuming that I'm going to see something that looks like this. C will be on this side, and then I'll see a little bit of D on that side. So that's what I think I'm going to see. Because here is my triangle, and it's not a isosceles triangle. So maybe this will be a little bit more here. So this is my top view. And then it says sketch the front. Okay, so the front, if I look at it from the front and I look at it from this direction right here or this direction back here, I think all I'm going to see is E. And E is going to be either like this, depending on which side is the front, or it might be the other way. This. Okay, so this will be the front. It'll either be A or E. And then my side view is if I'm looking in from the side, it's gonna look like a rectangle because I don't think you're gonna be able to tell that it's leaning. So you're either gonna be looking at either this side right here or this side right here, depending on which side you look at. So it's gonna look like a rectangle. This is C or D. That's pretty hard. It's hard to visualize, and I'm not great at the visualization. I'm going to go ahead and stop this video, and I may look up something. No, I'm going to go ahead and do this. Sketch the top, bottom, and side views of a square pyramid. Okay, so I can do a square pyramid. That's terrible. Okay, so there's my terrible square pyramid. So the top, I know, if you look down, you're going to see a square. And if you want to put those lines, those dotted lines to represent that if you can see depth, if there's depth perception, you can see that there might be. But if you don't have depth perception, then you'll just be able to see a square. So that's the top. And of course the bottom is just going to be a square. And then the side view is you're just going to see the triangle. So a cross section, and I'm going to go find some pictures of cross section, but a cross section is when you slice. You just think of having a super sharp knife and then you slice it, and then it'll be the piece that you're looking at, or if you picture slapping some paint on that and making a stamp out of it. But anyway, I'll stop here and I'll start my next video with cross sections.